we go.
When calculating anything, please remember to round to 3 decimal points, unless otherwise specified. So it says to round. Do not round until your calculation is complete. Okay. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when parent population is right skewed? What?
Right. Let's see.
I'm looking.
Yeah, I took a lot of notes this time on our textbook stuff.
Yeah.
Looking over.
Well, the n is the variable. So
that it can be skewed.
Yeah, I think it's going to be skewed to the right.
I always get confused whether it should be like the same, like if it's right, skewed to the right, or if it's like the opposite.
Did you see her little hand demonstration?
Mm-mm.
Yeah.
I think I missed it.
She said if you like trace the line of the histogram
Mm-hmm.
and you have to go this way, this is your right hand, so it's right skewed.
Oh, yeah, I saw that.
You have to go like that to trace the histogram with your arm. This is your left arm, so it's left skewed.
Mm-hmm.
But 5, a sample size of 5 is small.
Yeah.
So what is the shape of the distribution of means histogram when parent population is right skewed? I think it's still right skewed. I'm not sure.
That would make sense. Well, we can always do it again. Left.
That's
or
true.
Normal.
Okay, so when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? I think that's more normal because the more sample sizes you take,
the larger the number, yeah.
It becomes more normal, but I don't know, is 100 even a large number?
If the population is normal. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large enough to assure that the X number will be approximately normally distributed.
Yeah, and then I have on this, for this course, here I'll show you guys this part. Where, can you guys see that? 30. We will say that the distribution of the sample mean will be approximately normal.
Okay, so if n is less than 30, does it say it would be right skewed?
So yeah, so if it's more than 30, then yeah.
It'd be normal?
Yeah.
Okay, but what if it's less than 30? Would it be right skewed?
See that? I don't know. I'm looking right now.
It should be right in there where you were just looking, I think.
I don't see that because that's at the very end of the textbook chapter.
Okay, I'm gonna look this up real quick. All right. Okay. Let's see. When is X normal? Okay. Sample means. So you were looking at the very bottom. Okay. This says if the parent population is normal, the central limit theorem guarantees that the distribution of the sample mean will be approximately normal if the sample n is large enough. For this course, under 30, we will say the distribution, no. Yeah, if it's more than 30, more than equal to 30, then it would be approximately normal.
Yeah.
So I think.
Would it just be normal?
Yeah, it'd be a normal if it was 30.
Okay.
But if it was 5, so if it's less than 30, then I would think it would be.
Oh yeah. So would that?
You're right.
Right.
I think we're right. I think we're right on both of them, actually.
Okay. So we think it's skewed right.
The shape of the distribution means.
Okay. And then
Is this the same question?
it looks like the same question, doesn't it? Okay, question 4 is,
Yeah.
what is the shape of the parent population skewed
Oh,
right?
the ending is different.
The what?
The ending is different.
When the parent population is normally just. So then it would just be normal.
And what is the shape of the distribution mean?
Mm-hmm.
The parent population is normally just. That's normal. Oh, and then number 4 is when you are taking a sample size of n equals 100, it's still normal.
Mm-hmm.
Yeah. Shoot, is question 6 normal too?
I think so.
Yeah.
More than 100.
And it says the parent population is normally distributed, so it'd be normal.
I think so. Okay. When would the distribution of means be normally distributed? Okay. Okay.
If the population is normal, then the sampling distribution of X will always be normally distributed.
Or if the sample size is large enough.
Mm-hmm.
So it'd be data drawn from population normally distributed, and the sample size is large. So it'd be number is normally distributed, and the sample size is large. I think it's the second one.
What about the fourth one?
Well, no, because on my notes it says that the shape of distribution. When is it? Oh, let me read this. Distributions of mean will be normally distributed if the sample size is large or if the parent population distribution is close to normal. Is normally distributed.
So the first one, data drawn from a population that is normally distributed and the sample size is small.
That's false.
That one is?
The first one is false because it has to be, the sample size has to be large.
It said large or.
Pardon?
Can you repeat what you said one more time? Sorry.
Can I read my answer?
Yeah, to your note.
Okay, it says they're normally distributed if the sample size is large or the parent population is distributed normally.
Yeah, so in the first one it says normally distributed. So,
And the sample size is small, so that is not correct.
in your notebook it says that the sample size is large or
if
the
they're
population is normally distributed.
Right.
So if the first one is normally distributed, does it matter if the population size is small because it fits the answer?
I think it's the second one, but you can choose whichever one you want. We can see.
Okay. Well, I think the second one's right too. It just says choose all correct responses. So,
but it wouldn't be normally distributed if the sample size was small. It would be skewed if the sample size was small. Because the more you get, the more normally distributed it gets.
yeah.
And accurate.
Okay.
I could be wrong, but and I am a lot.
No, you're no. You.
Honestly,
Yeah.
this is like beyond. I have no idea.
Right. Number 8.
Okay, which of the following gives the best example of central limit theorem?
The most important concept in all of statistics.
Let's see.
I don't think B is correct. If the sample size, I think it's B8, but let's look at the C. If the sample size is large, the sample mean will be close to the population mean. That could be right too. Because
the central limit theorem is the theorem that can be applied to determine whether the data is normally distributed or not.
Or it could be D, because if the sample size is large, the shape of the distribution of sample means will be approximately normal. When I watched the video, the guy said central limit theme is about the shape of the thing and he said it's about the shape and it will be approximately normal.
So probably D?
Oh, I'm thinking. I think it's D.
Is large. The shape of the distribution mean approximately be normal. That seems accurate to what we were doing up above.
Yeah, I agree.
Yeah, let's do it.
Use the following information to answer the next 4 questions. Let X be a random variable with a population mean of 10. The population standard deviation is 6. Suppose a sample 36. From for this population, what is the mean of distribution of sample means?
So 10.
I forgot to get my calculator. I'll be right back.
What's the mean of the distance?
What's the mean?
What I have, what I have in my notes is the standard mean divided by the square root of the variable. N.
Yeah, that's what I see right here.
So if the standard deviation is 6,
6, and then square root of 36.
which is 6.
Mm-hmm. So 1? Would that be the answer?
Well, but wait a minute. Why do we need to know the 10 though?
Yeah.
Oh.
Okay, sample size is large, then mean will be approximately normal. Okay. Okay, so what I have in my notes is mean and standard deviation of distribution of sample mean. The mean of distribution of sample means. Okay, so that is exactly the wording of my note, and it's the standard deviation divided by the square root of
The sample.
You know, yeah. You know, maybe we need that 10 number for the other question.
Next one.
After.
Oh, okay. I'm going to put 1 because that's what we got, right?
Yeah.
Yeah.
6 divided by
6. Yeah.
the square root of
36.
36. 1. Okay. What is the standard deviation of the distribution of sample mean?
Standard deviation.
Well, isn't it 6?
Yeah, because when you square root it, it's 6. Is that all it's asking?
That's the population standard deviation. So this is asking for a standard deviation of the distribution of sample means. I don't know. Because the standard deviation up there is the population standard deviation.
Okay.
Are they different things?
Mm-hmm.
Well, the standard deviation, is 6. Oh my gosh. I don't really know. Let me see. I'm going to go back to our textbook.
Too many words that are so similar.
Means of the sample of the sample means, the means of the standard deviation of the, okay.
Is the standard deviation of the sample means. That's going to be
the standard deviation of the sample means is, I'm looking right at the textbook right now.
Yeah.
The deviation of the sample means is the standard deviation divided by the square root of the variable. Did we already do that?
Mm-hmm.
Is that what the other one asked for? Was
This one's involving that 10 number. No, it's not. Never mind.
Wait, what is the mean? Okay, wait a minute. Let me go back here, okay? This says the mean of the sample mean is the mu. This says the standard deviation of the sample means is the standard deviation divided by the square root of the variable. That's the standard deviation. Now, the number 10 says standard deviation, not the mean.
What's the mean of the distribution of the sample means if number 10 is 1? Question 9.
If number 10 is 1, what is the mean of the distribution? What is the mean of the distribution? So the mean of the sample means is mu. The mean and the sample means are always aligned with mu. Also, if you took larger samples than n equals 1, the standard deviation of sample means is always smaller than the standard deviation. Okay, so I'm looking in the textbook, and it says the standard deviation is the standard deviation divided by the square root of the variable. So I think the standard deviation is number 10 would be 1.
Yeah.
Okay, and what is the means? 10. I think they're yes distribution of the sample means, because there's no formula.
Yeah, the mean of the sample mean is that number, so it's definitely 10.
You think it's going to be 10?
Yeah,
Okay,
I think. Maybe I'm wrong, but
we'll check.
the textbook says that the mean is that U thing, mixed between a P and a U.
Yeah.
So,
Regardless of the distribution of the population, if the same mean is large, n equals more than 30, what would be the shape distribution of the sample mean? That would be normal, right?
Yeah, because isn't that like what the textbook had?
What does the textbook have?
Um,
Is greater than 30?
then it's normal.
Okay.
What theorem would justify your response? Wouldn't it be the law of large numbers?
No, I think it's the
central limit theorem.
Oh, is it?
The large number theorem is the sample mean will be close to mean if you have a large enough.
Yeah, it's definitely the central limit theorem.
Yeah.
Oh, okay.
Right.
Did we all get the same responses, or did we try something different?
On 7, I put first one too, but I couldn't.
You put the first one. Okay.
I did both the first and the second.
Oh, can you do both?
Mm-hmm.
Oh. Oh yeah, choose all. Okay.
All right, I submitted it. Oh, I think you're right.
You what?
I said, I think you're right. I don't think that top one was right.
How do we do on the other ones?
Yep, I got everything except for that number 7. So I think I need to go in there and change.
So everything was.
So I'm gonna go submit it and see if that only one is the
Perfect.
Okay. Oh.
So I just put that one and it's not right. But
So maybe the top one is.
So number 7 was the only one that was incorrect?
Well,
yeah.
So I got 75 out of 1. What did you get, Alexis?
I got an 89. I also got number 5 wrong. I put skewed right. Did I do the wrong one?
Oh, I put skewed
5
right.
was normal.
What'd you put, Alexis?
For number 5, I put skewed right and I got it wrong.
I put normal.
Oh,
and
is it normal?
For number 7, how much of that did you get correct? Did you get 0 out of 1 or?
I got 0.5.
You got 0.5? Okay, I got 0.75 clicked. So maybe we're just missing one more.
So you
think that's a good point.
So you think it's number 2 and what else? B and what else?
Let's see. When the distribution of means be normally distributed. Right skewed. Maybe, yes, the bottom one. It would be the last one. Data are drawn from a population that is right skewed and the sample size is
Oh,
totally missed.
Okay, I'm almost done. Sorry.
so number 5 is normal. Is that what we?
Yeah. Yep.
Okay.
I got that one right. It's normal.
Okay, I am going to submit this now and see. Oh, I got number 7 wrong too. I got 0.75. So it's got to be 3 of those.
Yeah. So the first, the second, fourth is what I'm thinking.
Okay.
Sorry, I probably wasn't clear enough.
That's okay. Hey, my neighbor just came to visit.
Oh.
She's sitting across from me right now.
Oh,
Waiting for me
fun.
So, Jaden. Anything else we need to talk
2:30?
about? Well, 4:30 for me, sorry.
Oh, okay. I was like, what?
What?
2:30 for you guys, 4:30 for me.
Yep.
Yeah.
Okay.
Sounds perfect.
Hopefully I'll be able to report back to you about a tutor then.
Oh, that'd be
Oh,
wonderful.
yeah.
Okay. Bye.
Okay.
Yeah.
Bye.